before we get started, how many of you are new to graph theory or graph database? Completely new. And how many of you have been working with the graph database or some in other form? Okay, few of them. Okay, cool, awesome. So my name is Suman Devnath. I'm a developer advocate with the data engineering team at AWS. So I mostly focus on data processing and data analytics and the data science side of things. And just recently, I've been starting to explore about graph database. And I just thought to share a few of the insights about my learning. So I'm no way an expert in this, but I thought that this is, if anyone is working around data and especially databases or even machine learning, I think graph theory is something that might interest you. You can connect few of the dots that how we traditionally store data and how it is different with graph theory. All right, so if you look at it, why we think about graph. If you traditionally look at a graph, like in this case, if you see, we have a name like Suman, lives in Boston, and Suman works with Carlos. So if you look at this, I don't have to explicitly tell you what is the schema and what is the relationship as such. But if you look at this image, you can figure out what we are talking about, right? So this is very intuitive, right? So it's very easy to understand when you have your data set laid around in the form of graph, right? So this is basically for your use case where you have connected data, right? And we are going to look into a few of them and look into the demo in a while. But the idea is this graph theory or graph database for that instance is very easy to understand. Now there are some challenges with the traditional or the other, not traditional, the other data. I would say that data sources where you can store your data, like databases, NoSQL database, and so on and so forth. So there you'll see that we traditionally acquire data using SQL, right? And if you have to build a system in SQL like what we have in Graph, you have to have enormous number of databases or tables, and you have to run a very big chunk of big queries using SQL with lots of join and so on and so forth. And over the period of time, it will become very, very complex, right? To even query for a simple thing. But this is very efficient in Graph, and we are going to see that in the demo. And the other thing is, this is not, I'm not a big fan of saying that the data doesn't have any schema, or all data have some schema in some other form. But if you look at Graph, it's pretty different. You don't have to define the schema in the first place. So that's where you have to do when you are working on any traditional database system, right? So we will get into what that graph database would look like, but essentially you have to talk to that graph database, right? So in the traditional database or any relational database system, we acquire data or query data using SQL. So for Graph, we use a different query language, and there are many, and we are going to see one of them today. But essentially, the Graph query language uses something like, it looks something like this. So let's say if I say someone works at Amazon, so there is something like this Gremlin. It actually travels through that graph, right? So it's not storing anything. All the data here, it's already stored persistently on the storage. So when I say data, you see this 3 pieces of data here. It's Suman works at an Amazon. All these 3 pieces of data, it's already stored persistently in the storage in the backend. And when you query that, the Gremlin is basically, as we just saw, this just travels through that path. And based on the query that you run, this Gremlin will traverse through that graph. Now, if I compare this with a traditional database, if you want to save this in a traditional database or any relational database, you might have 2 separate databases, one maybe with people, one with company. And if I have to fetch this information, I might have to run a SQL query with some foreign key and primary key, or maybe with a joint statement, right? So the same information is easily available with graph with respect to a traditional database. Now, this doesn't mean that all the use cases we can handle with graph database, right? This is just meant for the data sets where you have connected data, right? And we are going to see a few examples in a moment. Now, this is where the efficiency comes in. So when you think about graph, here in graph database, the works with, that is the connection, right? So, or the edge is the data, and this is stored persistently in the disk. And as and when you need, it just reads from the backend storage. But when you think about any relational database, if I just save this data or store this data, you have to query that, that you have to run that SQL query to fetch that information. And that is actually the metadata, right? So when because we will have two tables with some primary key and some foreign key, and then we have to run a SQL query. So that relationship comes out as a metadata, right? So every time you have that, you need that information, the system has to calculate that. Whereas in graph, it's there persistently on the system as well. All right, so now let's talk about how we can do this on AWS. So we have a service called Amazon Neptune. So this is our managed service for a graph database. It's cost-effective. It's you don't have to manage and provision all of that. Everything is managed by AWS, and we are going to use Neptune for one of our use case, and it scales automatically. We will not go deep dive into a Neptune, but I'll have some resources where you can go over, about things around Neptune. But we'll see a few of the architectural things. And Neptune supports various query language, so like Gremlin, OpenCipher, and Sparkle. So we are going to use Gremlin today. So Gremlin is basically one of the query language which you can use if you have a property graph. So what I mean by property is basically in a graph, if you have the data attached with its property, then you can use any language like Gremlin. And what is a property? Property could be like if you have seen the previous example, I had a node as person. So let's say that person is Suman, and I can have property attached to that. So what is the age of that person? What is the date of birth? Where that person lives, and all of that. So these all are the property of that node. Similarly, we had an edge, right? So edge was, in the previous example, was works at, right? So that edge can also have a property. So it could have property like work for how many years, right? What is the work location, and all of that. So when you store this data in the form of vertex or nodes and edges, and both vertex and edges have property, you can call it as a property graph. This is how you are storing your data in a graph database. So if you look at Neptune, this is basically the architecture of Neptune. If you think about it, we can look into Neptune at different layers. So first, in the application layer, you can think of the use cases and how customers or developers or any individual interact with the graph database. So this is where things like all different use cases like social networking, fraud detection, knowledge tree, and all of that comes into picture. So think about this. So today, when you go to any social media website, you add some friend, and then you get some recommendation that something like, okay, let's say John, you might be interested to connect with, let's say, some X person. So all this information, how it is able to know your tentative friend, right? So this is everything is done using graph in the background, right? So whether you take any of the leading social networking websites today, they all use some other form of graph when it comes to recommendation. Similarly, for fraud detection, so let's say you have you are running an e-commerce company or in a bank, and you see a lot of transaction happening from a particular account with the same account number, but in different location. So how these informations can be fetched together, and the system can detect, okay, this is a fishy transaction, and we should inform the respective entity. So all these use cases where you have multiple sources of information, but it is affecting a common entity, this is where graph comes into picture, right? So all these are use cases. And if you see here, the Neptune bench, workbench, this is something relatively new, not that all new, but this is something we are going to use in our demo, where you can have a Jupyter notebook connected to your graph database, and you can play around. You can have your test or development and run some query, and then once you are sure about what type of query that you want to run, you can put that in your production code and deploy it. And we have support for all the SDKs to talk to Neptune. Now, this is the next layer, how we store the data. So in Neptune, you have one writer. This is the database. Will have one writer, and you can have at max 15 read replicas. So what how it looks like is something like this. So you will have your primary writer in one of the AZ, and you can have multiple read replicas. So your application can read or inquire, query your data from all those read replicas, right? So and you can have at present up to 15. And if you think about the storage side, we store your data at 6 different places. So whatever data that you have, it's highly available and secure, and it's again distributed across multiple AZ. So it would look something like this. So we keep 2 copies of your data in every AZ, and you can just work independently from anywhere, right? We, in fact, I have not added this, but you can even have it across the region as well. Now, these are the few features like the Neptune offers. You can load your data in bulk from S3. We do have a few criteria, like how the column names you should have when you load data from S3. But we have an API which you can simply use, and you can just say, this is your graph database. This is the S3 bucket location, and it can load that whole data. You don't have to worry about those edges and vertex. Everything will be loaded, and you will have your graph database filled with your data, and then you can just run some query using Gremlin. Okay.
What format should?
So it could be in JSON or CSV, but it has a different set of. You need to have certain columns, a name, and I'm going to show you that in the demo. You need to have that. So if you have a data, like in my example, we are going to, I'm going to show you the query part of it using Neptune Workbench. But when I loaded this data, that data was not in that format. So I ran some, Spark job to transform that data in the format that which Neptune demands. And then you can use the Gremlin to query that. I'm going to show you that. Okay. And lastly, we have some service integration, like you can have backups. I mean, these are very standard across most of our services. You can also use Neptune ML, where you have the integration with SageMaker, and you can even use our machine learning stack to to get into some prediction on your graph data. And again, same thing with OpenSearch. We do have an integration with OpenSearch. Okay, so let me just jump into that demo. Okay, so first, what I'm going to show you is how this database, Neptune database looks like. Okay, so let's say we are in the console. Let me just increase the font so that it's a little easier for you to see. So you come to Neptune. Okay. And I just clicked, taking some time. Okay, so if you see, I already have one database, right? So if you see this is my DB instance, and this is the cluster DB instance. And if you see this, I have one writer, right? So you can have more number of readers and read replicas, as I just talked about. So to create a new database, I'm going to use this, but if you want to create a new database through the UI, the same thing is available through CLI or any SDK. You just have to mention the version of the Neptune. If you are getting started, we recommend always to take the latest version, and then you can define what is what type of database you want. Is it for test and dev or production? So you get less options when you select testing, and for obvious reason, when you select production, you can pick from any of the instance type. This is the instance type for your Neptune database, right? So, and this database is completely, if you let me just go back here. One thing I missed to tell you is this. If you see this, our storage layer is completely isolated from our compute layer, right? So whatever instance that you can select is basically we are selecting in this layer, right? So you can have any instance type, whatever we support, and then storage layer is completely isolated, and that's how you get the benefit of adding read replicas, because those instances are completely isolated from your storage. The storage is we always have 6 copies of your data, and your instance compute layer can talk to any of those 6 copies. Okay, so this is where you can select your instance, and here you can say whether you want to deploy it in multiple AZs or not. And one important thing is Neptune as of today is a VPC service. You need to have a VPC, and you cannot connect. You need to connect to that VPC. It's not publicly. It doesn't have a public API outside. So you need to make sure that you have all the security constructs in place. Okay. So once it is done, then you can create this database. And once this database is ready, what you can do is you can come to Notebook, and this is where that workbench comes into picture. You have this notebook here. I have created this, but you can always go ahead and create your Neptune notebook. In fact, this is a SageMaker notebook in the backend, and we just have few other tools installed and configured on top of it. Now, if I just click on this and open, I already have opened this. So let me just go here. So this is the landing page that you will see. Inside this Neptune, you will find a lot of tutorials you can go over. These are inbuilt, out of the box, you will get it. But now let's, I have one notebook inside this, right? Neptune data query demo. So I'm going to run through that. Okay. So first thing that it has some interesting thing, right? If you look at here, we can actually run the status magic function, where it will go and fetch the information about your cluster automatically. Because if you see here, I have not mentioned the cluster, right? But we don't have to do that, because SageMaker, this Neptune Jupyter notebook will take care of that. So you can see the status of your cluster, and here is how Gremlin, you can run a Gremlin query. So if you remember, we have only two things: vertex, which are the nodes, and the edges, right? Just to recollect, those nodes are basically like name of the airport or name of a person and all of that. And the edges is the connection, right? In the previous example, it was like work at Amazon, right? That work at was the edge. So in this use case, I have taken the data set of an airline operator. Okay, so I can see, okay, show me that G is for our graph instance. Show me all the vertexes, right? That means all the nodes, which has a label called airport, and show me all the details. Value map is basically a hash map. It will have all the properties of that node, and I'm just printing the first 10. So let's see what it shows. It shows all the different locations and this their origin code, right? So this is the data set comprises of all the airlines like United Airlines, Alaska Airlines, and all the airport locations, right? So like let's say Boston to San Francisco and all of that. So, and it has all the flight details for 5-6 months. Okay, this is the data set that we have. Now here, let's say you want to see show which airport has most origin flights in this period. So in this period means the period of data I have used, while loading it on my Neptune database. So the query here in this case is G.E. E means it's the edge, because we are now interested in show me the airports which has the origin flights. So I am looking for edges, and I'm saying that edge which has a label of flight connection, and we are grouping by the origin city name, because we want to know the origin flights. And if I just run it, you will see that Atlanta has the most number of flights, because I'm just grouping by the city, and then I'm just printing it in the decreasing order. And if you now look into the Wikipedia page of all the busiest airport, you will see that it's actually Atlanta. Although we have not used the whole a very big data set, but to give you an intuition that what it is showing is actually reflecting into the real statistics. Similarly, let's say if you want to know, the airport which has the most number of destination flights, right? So if you just run this, what we are running is, again, we are saying, show me all the edges which has a label called flight connection. And these are the fields which we had in the data set itself, right? And I'm going to show you that in a moment. And again, we are grouping by the destination city name, and we are just printing. So the point I'm trying to show you is, if you think about these queries, these are very basic queries that you will use to analyze, any as an airline operator. But if you have this data stored in an in a relational database, it would be like you have to run a big query, right? So like with lots of joins and cross join and all of that, and then you can get the information. Yes. Right. So this is, we are using a Gremlin. If you see, that is the query language to interact with the graph database. And the reason that it is more efficient is because all this information are stored persistently in the drive, right? We are not, it's just the, traversing through that graph. Now, to your point, you can always execute these queries, using your Python SDK. We do have Python SDK, and this is Jupyter Notebook for in any general case you will use for your testing and development, right? But at later point in time, you can do this, using your favorite SDK. Yeah. No, Gremlin is open source. Okay, there's an Apache project called Tinkerpop. So I'll share you a few resources, right? So there is a wonderful book by Kevin. Now that you asked, before I forget, this is the book that it talks about this Gremlin, practical Gremlin. It's a Tinkerpop project from Apache. It's completely open source. Yes, there are different query languages as well. Yeah, yeah. Yeah, so that's a little different with the syntax and all, but overall, it's almost the same conceptually. But think, Gremlin is most commonly used. Okay, so now let's go to another last query. If you want to see, I want to show you one interesting query where you can actually see. Oh, yeah. So here, let's say, if you want to see all the routes from Boston Airport, right? So we are interested in knowing all the routes. So we can say, show me all the vertex which has a label of airport with the origin as BOSS. And if you see this, you will see all the information in a graph format, right? So you can see all the city and what are the different airport that it has connected to. In fact, you can even search for airport here itself, right? So if you see it is able to search that. So this functionality is not coming from a vanilla Jupyter notebook. This is coming from your Neptune workbench, because that is what we have here. Okay, so now I think to answer your question, you asked that how we can upload this data, right? So because we started off with assuming the data is already there in the Neptune database. Now if you come here, yeah. So if you see, I am here at Gremlin load data format. So there are certain formats that you need to have. So you need to have two files. One is for vertex, one is for edges, right? So when I loaded this data set, I had a vertex CSV file and an edge CSV file. That vertex contained all the information about my airport and airlines, and edges had all those information. And I can show you the raw file, but these are the headers that we need to have: the ID, label. These are the mandatory headers that you need to have in your data set. So if you don't have, then you have to process that data using any of your favorite tool, so that the data is ready to be loaded on Gremlin. Similarly for edge file. Now lastly, if I have to show you this, let me just show you the data. So this is the raw data. If you see, this is very small. You cannot see that, but it didn't have those ID and labels and all those columns. So I actually ran some Spark job to add that. So if you see this here, I actually created I was doing some processing, and I was adding few columns which are needed for this graph database for Neptune. And I did this by using some processing. Okay, so this is what I loaded this data, and I added this H file, and there is another. If you see this, I'm just adding these columns which was needed for me to load the data in Neptune. Like if you see this, we have a from column, right? So all of this. So you need to pre-process that data before you load it to Neptune. Okay. So what I'm going to do is I'll load this. Maybe I'll put this in the slide deck. The GitHub repo, I forgot that. Which will have all the code which I executed to process that data, and also the Jupyter notebook if you want to have a look. And if you are interested, you can connect with me. I can share you because that GitHub repo, I've not added the README file. I'll add that, and you can have a look. Okay, so that's all I had. I just wanted to give you an intuition about what graph theory is and how you can work with that. And I would strongly recommend you to look into that book. That's written by Kevin. He's one of the principal architect with the Neptune team. It's a wonderful book. Yeah. So yeah, if you have any questions, yeah. Yes. Yeah, so it's a MongoDB is a NoSQL database, just like we have in AWS we have DynamoDB, right? Yeah. So Neo4j is one of the other database which we have in the market, which you can explore. But yeah, from AWS side, Neptune is the graph database offering that we have. It's completely managed. You don't have to worry about scaling and provisioning and all of that. Yeah, that's correct. Yeah. Mm-hmm. No, Neptune is, if you want to, create your own database, graph database on, on AWS using some open source, database, or, any, other specific, vendor, you can do that on, on a vanilla EC2 instance, but you have to manage that. You don't get the flexibility and all of that. But Neptune is, it's just a managed service within AWS. Yes, that's correct.